Good morning, dear students. In the last video, we have seen about the calculation of equilibrium constant of concentration and pressure for both heterogeneous and homogeneous equilibrium. And last, I have given just a summarized point of all those videos which we have finished till yet. Now, let us see here the application of equilibrium constant, which is applied to determine the extent of reaction, to determine the direction of reaction, and to determine the constant concentration of the reaction. The first is determination of extent of reaction. To determine the extent. Now when we say extent, what does it mean? It means to find out whether the reaction is in the forward or reverse order. That means whether the reactants are reacting to give the products or the products are reacting to give back the reactants. That is termed as extent of the reaction. It also means how much the reaction has occurred. The extent of reaction is based on the value of Kc. Here I have written, it also means how much the reaction has occurred. It means what is the amount of reactants to react has completed and what amount of product has produced. So, this extent of reaction is based on the value of Kc, equilibrium constant of concentration. That is, numerical value of K gives the idea of extent of reaction, but numerical value of K will not give the idea. The cross on the arrow, giving arrow, means will not give the idea of rate of reaction. It means how long it took to establish the equilibrium. So the value of K is not giving us the idea that how long the reaction has taken time to establish the equilibrium, but it gives us the idea whether reactant is reacting and product is produced, or products are reacting and reactant is produced, or even it can give us the idea that whose concentration is more, reactants or products. So, as per our formula, equilibrium constant is equal to concentration of product divided by concentration of reactant. So, what we can say from this formula? K is directly proportional to concentration of product and K is inversely proportional to the concentration of reactant, because product is in numerator, reactants which is denominator, which we can write in this manner, directly proportional and inversely proportional. So 1 upon R. So here what we can see here, if K is high, directly proportional, so concentration of product is high, but R is inverse, that means if K is high, R is low, and if K is low, R is high, and K is low, that means product is low. So this is what we are able to understand by this formula, which I have written also. If value of Kc is high, then concentration of product is high because directly proportional, and concentration of reactant is low because inversely proportional. If value of Kc is low, that is concentration of product is low and concentration of reactant is high. So now what value of Kc will determine whether the reaction has occurred to completion, almost completion, or it has not completed, or it is between the occurrence and completion, or not at all occurred. See, this is the extent. Now you will completely get the idea that what is the meaning of the terminology extent. Extent means the value of Kc will determine whether the reaction has occurred. Occurred, that means whether reaction has started and it is almost to the completion. One condition we can come to know, or it has not yet completed. There is another condition we can know, or we can say the reaction is between the occurrence and completion. That means it has finished, reactant has consumed 50% and product has already produced 50%. Or we can come to know that reaction has not at all occurred. So, if Kc is equal 1, now when we want to get the idea of this whole extent, there must be some numerology of the calculation of Kc which will give us little idea. So here we will have 2-3 situations where first we will discuss if the value of Kc is equal to 1, then value of both concentration, that is of product and reactant, will be the same. And when both will be the same, it also means that reactants and products are at 50% completion. So reaction has consumed 50% of its concentration, and at the same time product has completed its product nearly to the 50%. Thus, we have certain situations of Kc which will give little more or vast idea. Let's consider a different situation for Kc. And the first situation, if Kc is greater than 10 raised to the power 3, that means if Kc is greater than 1000, then for such a reaction, value of concentration of product will be very high. So products predominates. So here what we can say, product will predominate in the reaction. That means it will become boss and the reactant has to be little mild for him. So products predominates means more products would be present, and this gives the idea that the reaction proceeds to near completion where concentration of reactants is left very little at that time. Example of reaction which are near to the completion are H2 plus O2 when reacted at 500 Kelvin gives H2O, and if value of Kc is calculated, then it is 2.4 into 10 raised to power 47. See, our situation is Kc greater than 10 raised to 3. Now here you see 10 raised to 3 and 10 raised to 47. The another reaction is H2 plus Cl2 which gives hydrochloric acid at 300 Kelvin. Its Kc is also 10 raised to 31, and H2 plus Br2 at 300 Kelvin which will give hydrogen bromide, and its value is also 10 raised to 80. So all these values shows greater than 10 raised to 3. It means they are highly predominated product concentration reaction. So for this reactions, order of reaction of completion is in the order A is almost completed, then B, and then C, because they depends on the value of Kc, and value of Kc greater than 10 raised to 3 is highest for the first reaction, that is H2 plus O2, and then is H2 plus Cl2, and then is H2 plus Br2. So this is how, by getting the idea of Kc, we can come to know that what is the extent of the reaction, how far the reaction is going to be completed.